Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, my friend, to my YouTube channel, Drilling and Workover. This is Abdelaziz Gabr. I am accredited instructor in IWCF Well Control and IEDC Well Sharp. Also, I am accredited instructor in IEDC Mod Engineering for Basic and Advanced Mod School. Today, inshallah, it will be the first lesson we will talk in the course of Advanced Mod School. Okay, so in my opinion, the first lesson in Advanced Mod School should be related also to that in the Basic Mod School. So we will talk today about some important points, which are the solids and the solid analysis. Okay, so today inshallah we will talk about very important lesson. It's called the basics of solid analysis. We are talking about the solid analysis? Because you are reading a mud report, and from the mud report, the most dangerous thing that you will face is the solids. And also to put in your mind that, for example, if you need to get rid of these solids, you have to add more value or more cost to the mud in order to get rid of these solids. So this is very important, and in order also to know how to get rid of the solids without too much costs. Okay, so please give me pay attention to what I'm saying today because it's very important lesson. Uh, this is the mud. Okay, if you see the mud in general phase of the mud of any mud, it has solids and water or base fluid. So there is a base fluid, whether it is water or diesel, okay, and solids with cuttings with everything. So these solids, okay, are, as you see here, maybe drilled solids. It may be barite or heavy or wetting material. It may be emulsified liquids, for example. It may be polymers, maybe bentonite, maybe anything. So the total mud is composed mainly of solids and fluids. Okay, so the percent of solids, it depends on the or it determines the efficiency of the mud and the efficiency also of all the operation of drilling. So the solid analysis is very important point. Okay, can you imagine with me about the amount of solids that we are or need to handle? For example, if we start to drill 8.5 section for plus or minus 9,500 feet. Okay, so can you imagine about how many trucks, and each one of the trucks is 5 yard trucks, which means it's about the yard is 91, so it's about 4.5 meters wide, means 4.5 meters multiplied by 4.5 also meters. It's a square from 4.5 meters. Okay, so that we will need a cube. Okay, its lengths are 4.5 multiplied by 4.5 multiplied by 4.5 4.5, and we will need plus or minus 28 trucks of this volume to have or to handle all these solids. Okay, so do you have an idea now, or you have now an idea about the amount of the solids that are coming from the well, so that we have to handle these solids after we make some analysis to it. Okay, so let's start. The solid control. Okay, what are the goals of the solid control? The goals of the solid controls, we have to minimize the volume of percent solids as a total, okay? But we have also to keep the good solids to be kept inside the mud, okay? So as I told you, the mud contains the drilled solids and also it has the barite and the polymer. The barite and the polymer are commercial material or are useful material or desirable solids, which is very important, okay, to be kept in the mud. But the drilled material is like the cancer in the blood. The drilled solids are like the cancer in the mud. So we have to get rid of the drilled solids, but to keep the commercial solids in the mud. So that how can we make a solid analysis or to achieve this goal? We have to achieve this goal. What we can do? We have to utilize commercial high solid gravity or high gravity solids like barite, for example, for required mud density. What is this meaning? For example, in sometimes the mud engineers, okay, they don't want to add barite, but they will tell you we keep drilling and the solids will increase the mud weight in the mud. Actually, this is very wrong idea because it will increase the mud weight, but you know you have bad solids. You have too much drilled solids. You have cancer in the mud. So this is not the good idea. But you have to drill and keep the only mud the only weighting material to be the barite or something like this, or take all your weight from the high gravity solids. This is number one. Number two, to utilize commercial low gravity solids like the bentonite, the polymer, and the other material for the required viscosity and fluid loss reducer and the other parameters. It's very important too. Number three, to utilize a mechanical equipment or what's known as SCE, solid control equipment, to remove the undesirable formation solids. Okay, and we will talk about this in the next lesson in details. It will take plus or minus 2 or 3 sessions, so don't panic about this issue. Okay. Number four, we have to routinely monitor the mud system for quantities of each. Okay, by making solid analysis. Okay, so the solid control benefits, for example, why we are making a solid control? We are making control over the solids in order not to increase. Why? Number one, because the lower the solids, the higher the penetration rates. This is because if you have solids, so you take a space from the mud or a space in the mud, okay, or a space in the base fluid, and this will lead to make a high ECD due to high friction. High ECD means high friction. It will make high drag, high torque. You will get too much problem, so that it will make low penetration rate. So if we need to get high penetration rate, we have to make the solids as low as possible. Number two, to improve the rheology and hydraulics and the whole cleaning. To improve the rheology. How we improve the rheology? How we improve the yield point? Actually, as we have talked before, that the plastic viscosity or PV means that there is too much solids in the mud. So if we decrease the solid, BV will be decreased and so that the yield point will increase. So we will improve the rheology and also the hydraulics. As the hydraulics mainly we will talk about, it's about the pressure loss. Hydraulics mainly consider the pressure loss. So the more the solids, the higher the pressure loss. Okay, so if we decrease the solids, you will not get too much pressure loss, and also the whole cleaning is the same. Also, to make a better filter cake, as I told you, the filter cake is formed due to the high solid content, and the filtrate is comes into formation and the solids are making a filter cake. So if you have little solids, you will get thin filter cake, and the thin filter cake will not make a problem for you. But the thick filter cake, due to the high solids, will lead you, for example, to make differential stuck or something like this. So also the lower the fluid loss and less differential sticking or differential stuck, and also it improved the lubricity. Okay, if there is improper solid control or improper solids analysis, for example, what will be the result? It will result in number one, decreased the drilling rate due to the low penetration rate. Number two, thicker wall cakes, thicker wall cakes or thick filter cake. Number three, differential pressure sticking. There will be high differential pressure sticking. Number four, it will be increased mud costs. It will increase the mud cost, as I told you, in order to keep the solids in its range or in low range. So it will increase the mud cost because you will make too much dilution and pump too much fresh water or fresh mud. So it will cost you too much. Also, it will increase the gel strength. The high solids means high gel strength or progressive gel strength. And it will increase the pressure losses and the pump pressure will be too much and the ECD also will increase. Number four, or the last thing, it contributes to the possibility of kicks and loss of return or loss of circulation. Here, very important graph, okay, it shares or it defines or it illustrates the relation between the ROB in feet per hour and the percent of solids. And you will see here, as the percent of solids increases, the ROB will decreases. Okay, so it's reverse. Okay, this relation is not direct relation, but it's reverse relation. Also, the wall cake thickness, the filter cake as the filter cake as the solid increases, the filter cake thickness will increases also as you see here. Okay, so the filter cake thickness increases as the solid increases. And also the ability to have differential sticking. For example, the sticking force, okay, any force equal the pressure multiplied by the area. So the Fs or sticking force equal the P, which is the differential pressure, multiplied by A, which is the area of contact, multiplied by sticking coefficient. Okay, so we have here two cases. One type of mud which has very low solids and one has high solids. The very low solids give thin filter cake, thin wall cake, and this thin wall cake, okay, it will give very low sticking force. Okay, so if there is thin wall cake, the pressure differential is the same here, 520, and the sticking of coefficient is 0.2, and the area is 240, for example, square inch due to 1 inch width of the drill pipe against 20 length of the filter cake. Okay, so the width here is just 1 inch, 1 inch width. Okay, so the Fs will be equal 520 multiplied by 0.2 multiplied by 1 inch multiplied by 20, which is the length here, and multiplied by finally 12, which is a conversion factor. It will equal plus or minus 25,000. 25,000 is needed to make the pipe free. Okay, to make tension on the pipe or to make overpull over on the pipe. So 25,000 only is required as overpull to make the drill pipe to become free. Okay, but now if you have too much solids or high solids, it will give you thick filter cake and if it is the same here, it will result that you will need, for example, you will need to free the pipe, okay, plus or minus 100 pounds, 100 k pounds, okay, which is four double of the last value. Why this happens? This happened due to the solids. This was 1 inch width, but this is 4 inch width. Okay, so that all what we have talked about give you an important rule that the lower the solid, the better the drilling. Okay, so let's check about the mud solids and know each one of them. The PV or plastic viscosity and the yield point, okay, and gel strengths are all affected by mud solids, and we have talked about this before. This may be divided into two types. There is high solids or high gravity solids, and we can make abbreviation for it as HGS, which is high gravity solids. And the other one is called low gravity solids, okay, which is LGS. So the HGS and LGS are the mainly solids that we see in the mud. The high gravity solid or HGS, this is a term which refers to the weighting material added to a weighted mud to increase the mud density, like barite, hematite, calcium carbonate, all these materials. Also, it refers to any material with a specific gravity more than 2.65. The ideal weighting agent should have the following properties. The ideal weighting agent should have the following properties. Okay. Number A, to have a high specific gravity to minimize the volume of required for a given density. So this is very important to give a high weight with very low volume to be used. Number two, it must be chemically inert, which means it cannot make any reaction with the other chemicals. Okay. Number three, it has to be low abrasiveness in order not to make a problem in the bump or in the drill string or the other things. Okay. Okay. The most commonly used weighting agents is the barite or barium sulfate. But take care that as I told you that the barite is used only in any section, but it cannot be used in the bay zone. Okay, the only used in the bay zone is the calcium carbonate. The API specification for the barite is the specific gravity is 4.2 minimum, the particle size as a maximum 3%, it's more than 74 microns, and the minimum with the 5% is 44 microns. So take care about this. Other weighting agents commonly used include the hematite, okay, which is for the ferrous oxide, which has a specific gravity from 4.9 to 5.3, okay, or the most common is 5, for example, and the calcium carbonate with specific gravity 2.7. The hematite is used where the mud weights in excess of 150 PCF and required, for example, are required, for example, severely overpressurized area. The calcium carbonate is used for low weight system to minimize the potential formation damage, as I told you. So we cannot use it in the basin, for example, or where the reservoir must be stimulated by acidizing. Okay, this was the high gravity solid. Number two, there is very important things called low gravity solid or LGS. The low gravity solids comprises all the other solids in the mud. Okay, there is some commercial or desirable, and other is not desirable. So the commercial or the desirable, okay, the average specific gravity of low gravity solids is plus or minus 2.65 specific gravity. Low gravity solids can be further subdivided as desirable or undesirable. The desirable is the commercial solids added to provide specific for mud properties like the bentonite, like the polymer, like all the chemical which makes good functions in the mud. And the undesirable, which is the drilled solids, which are the solids that are coming from while drilling. Okay, and here, sorry, and here we should distinguish between the cutting and the solid. Cutting can be separated by the shell shaker. It's big, it has big volume, but the solids are too much. Okay, and they are some are dissolved and others are not dissolved. Okay, so we have to take care of this. The desirable solids, like for example the polymers, or the bentonite or the other chemicals. Okay, now there is very important thing or very important idiom. It's called the corrected solids. And what is the difference between the corrected solids and the retort solids or the total solids? Okay, the corrected solids or the retort solids are the total solids in the mud, including the dissolved solids like the salt. For example, if you make the retort, okay, if you make the retort and you take for example 50 cubic centimeters of the sample and make retort for it, and you will make distillation, you have the distilled water in the pipette. So if you make subtraction from the volume, it will give you the total solids. These solids include the solids, the dissolved solids, the salt, or the solids. Okay, this is called the retort solid or the total solid. But what is the meaning of corrected solids and why we take it into our account? Corrected solids are the total solids minus the salt which is dissolved in the base fluid. For example, they are the total solids in the mud without the dissolved solids like salt. Okay, so we have to take care of this. So the correct solids, what's the meaning of correct solids? This is very important question in any interview. It's equal to the total solids minus the salt volume. But take care, my friend. All the mud you can take to get the solids through the retort test. But the formate mud, you can calculate the solids only by some equations or Excel sheet or something like this. Like the most common one here we use is called for baroid here or for Halliburton. It's used here for the potassium formate base or drill in fluid or something like this. You put here the specific gravity and you put okay. You can use here which one, for example pound per gallon, for example, if you need. So here you put the pound per gallon here and the density of the filtrate or water or whatever. You make the filtrate and you know its density, and you make the total mud here density, and so you get the low gravity solids from here. And this is the filtrate analysis, and this is the water analysis. And for this type, it's called potassium formate. This is not a big problem. There is another types, sorry, that we can use also. Also, there is very important thing in order to make the solids very low. Okay, very low. How? For example, if I need to mix water 10 ppg, 10 ppg. Okay, so if I put water, water based mud, if I know put the water, it's 8.3. Okay, and after add the bentonite and the polymer and the blah 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 blah, it will become 8.4. Okay, so if I need to increase the weight from 8.4 to 10, I will add weighting material. Okay, so I will need some bags of bright, which means I will add solids. Okay, also if I need not too much solid. Okay, if I don't need high solids, so I can use the salt tables. But or for example, if I can add salt, for example, up to 9, I will add NaCl, for example, until I reach to the 9. So I will add to the mud 45.6 pound per barrel, and it will reach to 9. Then after 9, I will add just 1 pound. It will be bright. But how it depends on what? It depends on the salinity of the formation in order not to make osmosis phenomena. It depends also on the many things that I take into my account while making a program or while making a mud proposal or something like this. So take care. This is very important. I use the salt tables, or I use the salt in order to make the solids very low, and also not to use too much, not to use too much solids or not too much bright. Also, why my some solids may increase in the mud, also due to the purity of the material. For example, the bentonite, it is not 100% bentonite. There is something is called ABI bentonite, ABI barite, and we will talk about this when we are talking about the quality control and the quality assurance for the material. But take care that the barite is not 100% barite. Bentonite, it is not the same. So it is mixed with some impurities which may increase the solids also. The density of mud additives, as you see, the material, for example, the oil or sulfur oil is 0.84, and in BBG it's 7, and in pound per barrel it's 294, and here in BCF 52. And water, for example, it's 62.4. The low gravity solids here, for example, it's 2.6, okay, and in BBG 20 to 1.7, and the bentonite is the same. The calcium carbonate is 2.7, and all these chemicals that we are using, barite, hematite, in different units. Okay, so take care of each one. Some notes about the mud weight material. The barite can increase the mud weight up to 150 bcf, and hematite about 187 bcf, and the calcium carbonate up to 110 bcf. Take care of this. The barite has specific gravity 4.2. The hematite 5 is specific gravity. Calcium carbonate 2.7, and the low gravity solids 2.65. The sodium chloride has maximum weight of 75 or 74, for example, and maximum salinity of 188,000 milligram per liter. Calcium chloride has maximum weight 86 bcf and maximum salinity 343 34,000 milligram per liter. The potassium chloride has maximum weight of 72 bcf and maximum salinity 134,000. Okay, and the sodium formate has the mud weight, for example, of 10.8 ppg, potassium formate 13.1, and the cesium is 19.2. Okay, today, okay. Today, inshallah, we have talked about the solid analysis, and inshallah, tomorrow we will talk about new lesson in the solid, which is about the solid control. Thank you very much today, my friends, for this lesson, and inshallah, I hope to make another lesson with you in the next time. If this video appeals to you, please share, like, subscribe. It's your channel, not mine. And thank you very much. Goodbye.